So here's another student, and really do like the answers or responses coming from here, from this student. So let me just look at the question. Shows a diagram of a part of the simple AC generator, and the magnet, the coil of wire, and here's the magnet. There's the axis, the axle, or the axis of rotation, coil of wire, and which are carbon brushes. And because it's an AC generator, these are slip rings. Otherwise, if these were like a DC generator, these would have been split rings. All right. Component C is made of soft iron. Describe the effect of the component on the generator. It increases the alternating current produced as it's soft iron material. It becomes a temporary magnet. It produces much stronger magnetic field lines. Excellent, very good. And then I'm looking at this part where really the coil of the generator rotates at a constant speed of 2 complete revolutions per second. So 2 complete revolutions per second. Have they said 1 complete revolution per second, then in 1 second there should have been 1 wave. But because they said 2 complete revolutions per second, you should have two complete oscillations. And then the coil is in the position shown in figure 8.1. So in this position, because in this particular position, if you look at it, the coin this way, what you're looking at, it would cut the magnetic flux. So there will be maximum EMF induced. But if the coil was in the vertical, it's in vertical position, so it cuts the magnetic flux because the magnetic field is like, let's say, north to south, like that. So, but when it's in a horizontal position, the magnetic flux change would be minimum, because it would be moving parallel to the magnetic flux. So it should be maximum to minimum. So this is like excellent diagram, superbly done, very good. I mean, it's like brilliant. So in the power stations, the transformers are used to step up the voltage, electricity generated before it's transmitted through the cables over long distances. Explain the advantages of transmitting electricity at high voltages. So we do that in order to reduce the current. We want to reduce the current because we want less power losses and less heat energy being generated. So high voltage means low current. Excellent. See, and so high resistance and thinner wires can be used, which are cheaper, and also there is less power loss, less energy wasted as thermal energy. Excellent. 2 marks there. And this one's basically a ratio, because what you see is the power station generates electricity at this. So this is the input. So primary coil, a transformer steps up the voltage to this, that's the secondary voltage. The primary coil has this many turns, so certainly we should have more turns in the secondary, right? So if you use the formula Vp over Vs, Np over Ns, so Vp over Vs, Np over Ns, and then Ns turns out to be 300,000 times 450. Nicely done, good, and good there. And we're getting super marks over here. It's not just that many students you would get 9 out of 9, but this, you are happy to give away those 9 marks because it's well earned. Good job.